Good morning, everyone. Hope you can hear me well. The topic is all about mindset shift in big data testing. So, basically, first, whatever things you learn, so first you have to try to learn from the big picture. Okay. So first I will go through that, and basically here what I'm going to cover is one part. Okay. So when we are learning things, we have like what part, why part, and then how part. Okay. So more or less, most of starting from how part. So here, so to be clear, this is about what. Okay. So before go to how, because this data testing is a very big part. In that case, before learn how, let's learn what. What is this all about? Okay. That is basically the industrial automation, cognitive AI, there is speech recognition, etc. Learning, algorithms, machine learning, and also as a big data thing. So today I'm going to cover this. So why we need to learn this is kind of part of big picture. Okay, this is the big picture, and this is a very small one. But again, then there is a big picture to cover. So here, what is the data formats? So we are basically working in that structured, semi-structured, and unstructured. So structured is basically, we are more or less working with this structured data, like these databases, ERPs, ERP data. Okay, and the semi-structured, this means XML, JSON files. Okay, those are not straightforward, but that's why it's semi-structured, and then unstructured. So these are the main things in today's world. So audio, video, and images. So okay, so these are the data formats in that we need to looking at. Okay, so these are the kind of view. So it's only 2020. So you can see that how big data is all about. So it's exabyte. So we have like terabyte, petabyte, and exabyte. So you can see the unstructured data is huge than structured. Okay, this will give you an idea about what we're going to talk about. Okay, so main actors of this context. So before go to the QAs and all, what are the main actors in here? Okay, so data scientists, algorithms, and they are creating models and systems. Okay, and then data engineer, I will tell you the flow. So data engineers, they are more or less us. That is, computer guys. So they are helping to extract things, and then they are keeping data in a warehouse, etc. Data analysts, they are the people who basically working with business issues. So they are the people who present things. Okay, so these guys, the data engineers, are, as I mentioned, the facilitators. So they are basically extracting data from those streams and support these two guys to make things better. So in that data, these guys are using to create algorithms, systems, things, and these guys are basically using for business purposes, as a business intelligence, BI. Okay. So more or less, these are the three actors, but in some articles they say there are four, but I'm taking three actors. Okay. So these are the like tool-wise, I would say these are not only, but like say for an example, data scientists like Python, R, SQL, more or less languages. The developers knows about these. The skills like statistics, mathematics, etc. So scientists, data engineers like Java, Python, SQL, Hadoop. These are like certain tools. and skills coding, big data, administration, cloud, computing, analysts like Excel, SQL, BI, like Microsoft BI, business intelligence, skills like domain knowledge. This guy is more or less dealing with the actual issue. So we need to have domain knowledge, communication, and other technology. So these are the other form of seeing the actors. Okay, skill set. And now we are 4 V's of big data. So we have the volume, so the size of the data. So there are a lot of data and we need to deal about this, the volume. Then variety, the different type of data. So as I mentioned, structure, non-structure, semi-structure, there are different types. And then velocity. So how frequent we are coming into our site. So velocity is there, and then veracity. That's the trustworthiness of, I will tell you, when I'm talking about the ELT, ETL, is also very important. What is the security thing inside the data? So that is veracity. This is the 4 V's of big data. So we need to know before try to deal with or maybe develop with or test with these things. Okay, so we basically is QE mindset of this big data testing. So basically we have 2 positions, that is technical QAs as well as non-technical QAs. So technical QAs, that is basically you needs to learn certain different tools. Okay, so we can see the technical, you know, the testing techniques, data testing methods, SQL and data automation and visualization. Like there are a lot of tools like Apache Hadoop, Spark, something like the Power BI, etc. So that is not very easy. Okay, I will deep into this later on. So this needs to have a kind of certain knowledge base rather than our fundamental knowledge in quality assurance, like we are planning, testing, test case writing, something like that. So here non-technical means, so let's say we have a data scientist or the developers there, and then analysts there, but we are supporting them to create meaningful results upon their data set. So let's say we are writing test cases and they are giving us some kind of file, and then by looking at the visuals and etc., or looking at the pie chart etc., we are doing non-technical. Say for an example, in here BI tool, I think really have some experience. So what we are doing is basically they are giving us the file, and then we are comparing, we are verifying the charts and all. So that is more or less non-technical. Okay. So these are the 2, actors or positions we can see. So I mean, these are not, hard and fast. Okay, we can define, but and then non-technical. So this is basically we can say functional testing and performance testing. So likewise, so as I mentioned, we can do normal validations. Okay, like data sets etc. So we are not deep into these tools, specific tools. So we can do normal test case writing and do the functional testing, and also we can do the performance testing on those applications. So that is, even though this is, we can say doing performance testing is kind of technical, but in this particular topic, to me at least, this is kind of non-technical, because we don't need other specific tools or knowledge base. So this is basically we can let's say there is an application we can do, let's say there are a lot of data, and we can do a normal performance test and see, okay, how is the behavior of that application. So we can do this without much knowledge of these tools and methodologies, etc. Okay, so this is again very important. So sample testing is application for functional testing. So this is the test data or the big data thing. We have a lot of insights here. So what we have to do is basically we have to create a subset. We have to create a subset and then create our own logic and create our output. And then let's say there is a person who creating the BEI and all those things. There are tools as well, or the customer. So then we can compare the results. So he needs to create this upon our data set. Okay, not like this. So if we are doing testing on this chunk, we don't have any clue, right? There are a lot of noisy data here. So we have to create our own set of chunk and then start writing our own logic and then compare the output with the given file. Okay, so this is the way that we can do the normal functional testing. And then, so before we go to the technical quality assurance, we need to learn 4 layers of the data processing architecture. Okay, so this basically try to understand the data collection layer. Okay, so we have the streams, and then what we have to do is connect to the data source and take the data out of that. So in that case, you can see transforming data from data source to data platform in streaming mode or batch mode. So there are streaming mode and batch mode as well. And maintain the information such as how much data is pumped into the data platform. So that is also a consideration when we are talking about the extracting. So these are the tools like is like stream, Apache Kafka. These are more or less data cloud data flow. These are more or less tools. There are many, right? To use for extract data from these sources. And then the second layer is processing layer. So more or less they are working in a staging environment and then they are processing. So this is more or less I'm talking about the ETL. Okay, I will tell you later what is that. Read data from storage and apply transformation. So it support popular programming language and programming languages. So you can see some of the tools, some of the languages, and also this Apache Hadoop and Spark kind of thing. So these are more or less processing tools. So in here, what we are doing from processing is or transformation is structuring, normalization, denormalization, and cleaning. So in that case, we are extracting and then transform the big data. Okay, so I'm basically talking about the ETL process. I will tell you later. So then the third thing is the storage. Okay, so we are extracting and then we have a staging environment. Okay, we are processing and then we are storing to a storage. Okay, so here this is the third layer. So we have normal relational databases and also the non-relational databases. So here more or less we are using non-relational databases because there are huge data, right? Video, things like that. So they say we can use this non-relational data like Cassandra, etc. There are many. Okay, I took only few. So this is okay. Now we extracted. Now we are processed, transform, clean, and then we are storing. into our warehouse. And then the fourth layer is a presentation layer. So analysts are working more or less with this. Okay, analysts and more or less we or the QAs are more or less working with this. So we have Power BI. There are many tools, Excel, etc., etc. So now we are. So this is the business intelligence part. Okay, we are taking the raw data and we are cleaning in them and then put it to a data warehouse, and the scientists, they are taking those for creating algorithms, different kind of things, and BI guys are working with the organizations, and they are finding solutions upon this data. Okay, the Moscow word, right? Must, could, should, something like that. So it's also a data separation. So then we are taking, I would say answers for their questions by looking at these graphs, and also in CI we are doing, we are transforming into a nice graphs in using Power BI, and we are taking upper management taking decisions upon this. So basically at the moment, yes, as QAs we can help on this more or less, not the other parts, because we don't have much knowledge on that. Okay, and then this is the technical quality assurance, more or less. So data, we can test the data extraction type of testing is within your data testing method, so that you verify that all the data is extracted, collected correctly. So in that case, that's why I said, even I don't know how. Okay, so you have to think that. Okay, so I don't know how, but this is the thing we have to know. Okay, so if we wanna be a technical person in quality assurance at least, so you should need to verify the extraction and then data processing part. So using as I mentioned, there are certain tools like Techtalk, etc., and then we need to verify, okay, this processing part is correct or not, using subset or something like that. Okay, and then data presentation. So in this case also there are certain querying, we need to have a database knowledge, etc. So in that case, we can think of, rather than functional and performance testing, we can think of these three areas. Okay, for all these areas we need technical capabilities than current knowledge we have. In that case, we have a thing. We have to learn more on these areas, how to do or how to learn these tools at least. Okay, and methodologies. And ETL versus ELT. Basically, so this is what I described in my presentation. Extract, transform, and load. Okay, so here what I mentioned is we are extracting and we are transforming and we are loading. But I can't say, but this is more or less established way, but this is the new way. So extract, load, and then transform. ELT. So here what we are doing is we are extracting from data sources and straight away we are adding it to data source, and then simultaneously or synchronously we are basically transforming the data. Okay, I will tell you what are the differences or something like that. So ELT process at a glance. So this is what I have mentioned. Okay, these are the sources. We are extracting and staging thing, and then load data warehouse analysis. This is ETL. Okay. So what are the pros and cons here? Here basically, okay, so this is kind of slow. Okay. So we have, because we have to transform. So to take the data out, let's say we have a, let's say analyst or scientist or something like that. They need to get the data out of this. It takes time because we have to transform. Here it's kind of speed because we are straight away loading into the warehouse or database. Okay. And when we talk about security, so here we are more or less talking about the loading. So all the junk is here, but here we are cleaning, we are transforming. So the data wise or security wise, this is the way. But here basically we say all the junk here, since we are expecting or loading straight away, security wise this is not good. This is the clean and the normalize, etc. And then the other thing is basically processing we talk about, and security, and also when we talk about the storage capacities. So here we are basically transforming, and this is less, right? We have important part, but here we may need more storage, and then if we are using cloud, then we have to pay more because it is speedily increasing the capacity because all the junk we are loading to the database. Then other thing is that the last one, and it is most important, because here we are normalized or clean, and here we have all the data. Okay, even though it is junk, we have. So now they say, okay, for especially the scientists, if we can use this raw data, they can create more methodologies because it has all this data here. It's not clean. So if we are using this one, they have limited capacity of querying and all. So that is also a very good thing or difference in this extract, transform and load, other than extract, load and then transform, because they can do a lot of querying here and get more data out of that. But security wise, this is not. Because only done through the rubbish is there. So this is the, I would say, pros and cons or difference in ETL and ELT. Okay, so you understood. Okay, so the summary is all about traditional testing and big data testing. Traditional testing supports structured data, and big data testing supports all type of data, more or less. Okay, we are supporting here semi-structured as well, more or less. But normally in day-to-day life, we are dealing with the structures. For example, CEO, something like that, or whatever sort of rules, we are more or less structured, right? Here, all type of printed data size requires special environment. Here, special environment because there is a big use Excel based macros or UI based automation tools. Here we have to have specialized tool set. So in that case, we have a specialized skill here. And operations knowledge in one case, the highly qualified skill set is necessary. In that case, so whatever I have to tell you is that if you want to become a tester to go into this area, even though it's a developer or a QA, needs to have a certain skill set or different skill set than what we have. Especially when doing QA, we have a thing called verifying, right? So validation. So checking. So in that case, we need to have a certain tool set or skill set rather than the existing things. Okay. So conclusion is more or less to become a technical tester. Okay, knowledge of SQL, PSQL, PLSQL, 3 languages, have good knowledge in business intelligence tools like BI from Power BI side, Power BI visuals, Power BI DAX calculations, measures. So it should be, practice. We should know. Then we can, extract things from the sample and we can say, okay, this what you show in the graph is not correct. So that is what we have to do. So in that case, these DAX calculations and very important. In CAPI, they are using this. So if we can write something like this, we can test rather than asking do I use something like from customer or the developer. So this is basically what I'm. Final thing is how to be a independent QA here rather than depending on other test data or other parties. Good Excel knowledge and hands-on experience tools like Adobe Spark, etc. Okay, so this is basically finally while building knowledge towards technical data engineers and data analysts to verify the data accuracy and compliance by writing suitable SQL scenarios. So yeah, while upgrading, what we can do is basically work with pair with the developers, pair with the analysts, and write proper test cases and work with them. But to become a proper QA, we need to have this kind of skill set. Okay. Yeah. So, if you have any questions, you can show. So, this is all about what we need, what sort of areas we need to touch, we need to read, and how we need to, upgrade our skill sets. Thank you guys for the participation.